Yuri and I here for the first round of common questions Regents review. So we're going to go over like 4 to 5 topics per each of these assignments. You see 6 of them on your review schedule, and we will go over some of the more important ones, kind of mix those in throughout the other ones too. So we're going to focus on 4 today. So we're going to go through these different. Got my folder of all these different things. Not a bad idea to copy some of these down as we go through them and have your own sticky note folder of things to kind of go through. If you had all of these sticky notes memorized, you'd be in really good shape for this final. So first one, way back to not too far long ago, solar energy. How do stars make energy? When you see anything to do with stars making energy, sun making energy, hydrogen turns into helium. That's lighter elements turn into heavier elements because hydrogen's light, helium's heavy. This is the product. This is the fuel or the waste, sort of, can be referred to. So if there's more hydrogen, it's a young star. And as the helium goes up, the star gets older. That indicates that it's an older star. Okay, this is called fusion or nuclear fusion. This is our crossword clue to help you with that. So sun, fusion, they go together. Nuclear fusion, fusion, hydrogen fuses together to make helium and crazy amounts of energy. So old stars have more of the heavy stuff. Younger stars have more of the light stuff. Another concept that's on here is this one here. September leaves need raking. South to the left, north to the right. All things, ocean currents, wind, anything that's moving in the northern hemisphere takes a right-hand turn. Doesn't matter which direction it's going, it's always a turn to the right. Southern hemisphere to the left. So you got to memorize that. They love asking questions about Foucault's pendulum, Coriolis effect, that proves or supports or gives evidence to the Earth spinning, the Earth rotating. So if the Earth spun faster, there'd be more Coriolis effect. Things would turn faster. They would be more drastic. So anything turns to the right in the north, south to the left. Coriolis, Foucault, spin, Earth rotate. Another one here. We've got some redshift is also called the Doppler effect, cosmic background radiation. We're just going to ignore that phone right now. Of course, they're calling now. That has to do with the Big Bang theory, the idea that the universe is expanding. So when the universe is expanding, that makes redshift happen, which is called the Doppler effect or cosmic background radiation. All of those are evidence for the universe getting bigger. Sometimes you will see that as a diagram like this. These are spectral lines, okay? It doesn't matter where the lines are, red away. The lines, do you see how these lines are getting shifted towards the red side of the diagram? If the diagram was flipped, the lines would be pushed towards the red, which would be the other side, okay? Red away. Once in a while, you'll be asked about a blue shift. That would be like Andromeda galaxy that's moving towards us. Most things are moving away from us in all directions that we look, which supports the idea that the universe is expanding. So anything to do with redshift, when we're looking at stars, the light looks more red. That's also called the Doppler effect. And then there's a separate thing called cosmic background radiation that also supports the Big Bang theory. Okay, I think we have 2 left. Another crossword clue. Jovian are the Jupiter planets. Earth are the terrestrial planets. So the Earth planets are all rocky and small. If you use your ESRT, they also end up having longer days and shorter years. You can look those things up, though. You just got to memorize that Jovian is the Jupiters. They're the gas giants. They got a lot of moons. Some of them have rings. They're all really big. They're a low density because they're gas, and objects can go right through them. So you would see things like a lot of craters on rocky planets, not so much on gassy planets because they're made of gas. Oh no, Yuri jumped into the pool. Yuri's gone. And then look at this diagram here. Visible light, greenhouse effect, greenhouse gases. Short waves come in, most common being visible light. UV rays come in too, but most common is visible. Short waves in. The Earth absorbs the heat and then it re-radiates out the terrestrial radiation. The longer waves go out. So short in, long out, visible in, infrared, which INFRARED, can't spell, can I? Infrared out, that's called terrestrial radiation. The greenhouse gases help to catch and trap the terrestrial radiation. It's like a blanket. So, carbon dioxide is a good greenhouse gas. It traps the radiation, infrared radiation. Methane, CFCs all trap infrared radiation. Water vapor does too, as does clouds. So all of those things trap that infrared radiation and keep the Earth a little bit warmer. So short in, long out. I think that covers everything. You get one submission on these common questions, so make sure you're really thinking through the questions, and it's not an edit situation like the assignments throughout the year are. Good luck. See you next video.